Hello everybody. As you may have seen in my previous video, I got 9th place in this div tree, assuming no hacks will happen. And for this reason, I decided to make videos on the problems given today. I started with problems A to D. And now in this video, I will cover the problems E and F. And then in the next video, I will cover G and H. So let's begin. In problem E, we are given a binary string of length n, and we want to find whether we can actually make it equal to 1, and if possible, what is the biggest value of k for which we can do it. For this problem, I would say that there are two major difficulties in terms of getting it done. The first difficulty is that we want a way to simulate fast the process of reversing. And in order to do it, there are two options. You can either use some really complicated data structures to tell you that whether you have a character at a certain position equal to 1 or 0, or you can think at an algorithm where you will always reverse characters on a prefix, or starting from prefixes and going all the way to the suffixes. And second, we need to also figure out a strategy to do it. And it turns out that no matter in which order we apply the operations, we will get to the same thing. So if we do the same operations, of course. And based on these two things, we can now have an algorithm where we will go left to right, and we will keep track of two counters. So we will keep track of a counter that keeps track of how many changes we've done so far, and also an array which will keep track of whether we had a change starting at a given position. Why is this array important? Because we want to keep some sort of a sliding count. Because in order to see whether the current square is 1 or 0, we want to be able to use this sliding count in our advantage. So basically, if we have something like k equals 3 and we reverse here once at position 0, let's say we reverse again at position 2 and we reverse again at position 6, the sliding count will be 1 after position 0, 1 again, 2 here. We will decrease it by 1 because this is too far away. We will also decrease it at position 5 because this is too far away, and we will also increase it by 1 here. So we have this sliding count, which will help us see whether the current square is a 0 or not. Because if it's a 0, we need to make everything in that substring of length k 1. And using the sliding count, as well as the observation from above, we can conclude that now we have this n squared algorithm, which will tell us whether we can make everything equal to 1 or not. And it turns out that it's actually enough. And all we have to do is just to implement this carefully and to deal with the cases. As you can see, at first I misread the problem and I thought that it can be 0, 2. We can make it 0, 2, but then I realized that this is not the case, so I just had this weird for loop. Then as you can see, I have the sliding count as well as the change array. And here, if it's too far away, we need to decrement the number of changes. Otherwise, we have a bunch of cases depending on whether we need to change a variable or not. And of course, if it's too far, if it's too close to the end and we can't do it, then we can't do it. And if we can do it, then we set a new maximum. I go in increasing order without too many complications. So this was problem E, a problem where we needed to be careful about how to deal with, let's say, sliding counts and things like that. And we can move on to problem F now. In problem F, this is probably the most interesting problem in the contest. And we have these 4 numbers from 1 to 4, and we need to find out how many times Bob wins. So Bob wins if the bitwise XOR of the numbers is 0. And Eve can remove one number at a time. Now, in order to solve this problem, you might think at using some sort of a DP, where you have something like DP of 4 dimensions, and you would have something like DP of ABCD, which tells you how many times you win if you start with A once, B 2, C 3s, and D 4s. And this is actually a good approach, but the issue with it is that it's too slow. You would get 200 to the 4, and even if you pre-compute all the answers, this is not going to be good enough. So we need to make some observations. We can see, let's talk about the binary representation of 1, 2, 3, and 4. So we have 0, 0, 1, 0, 1, 0, 0, 1, 1, and 1, 0, 0. So if you notice, 4 has a bit that no other number has. And if you know, when it comes to bitwise XOR, in order for some values to have bitwise XOR equals 0, the bitwise XOR of every bit has to be 0. So you need to have even number of bits on each position. And using this observation, let's assume that we don't have any 4s. If we don't have any 4s, then we can apply this DP knowing that we don't have this dimension. And now, how do we deal with 4s? How do we integrate them here? Actually, it turns out that if we can get to a state where the bitwise XOR of these three is 0, we can just alternate removing 4 as many times as possible. And this brings us to the idea of running 3 DDP for everything 0, 1, for 1, 2, and 3. And then we know that the number of flips we will have to do will be something like number of 4 over 2, because we need to have an even number of 4s. And based on that, all we do is just to pre-compute DDP of 200 cube, and then we just add up the number of 4 divided by 2. And this turns out to be quite a short solution. 4 doesn't matter that much. This was literally the first thing I wrote when I started this. And then I just have these 3 for loops. I do the XOR, and of course if the XOR is 0, then we increase the answer by 1. And when I read the input, I just rely on the answer found earlier, and then I just add P over 2. So as you can see, I relied on pre-computing in order to get me to the final answer. So as you could see, these two problems were quite different from the previous ones. So in E we had to rely on DP on some sort of a DP combined with a sliding window idea once again, but also some prefix computations in order to get it done. And for F, we needed to pre-compute a 3D DP in order to see that we can actually rely on the 4 in a different way. So if you enjoyed watching this video, please like the video, subscribe to the channel, and let your friends know about my channel. And also, if you want to be coached by me, check the video I made yesterday on my 5-year anniversary as a coach. So once again, if you liked watching this video, cheers and see you next time.